In lesson 40, we're going to talk about what's called the quotient rule for exponents. And so far, we've had a rule involving exponents also. As you'll recall, if you take a squared times a to the fifth, when you multiply powers, we add the exponents. So that's a to the seventh. So really, that's the multiplication rule for exponents. When you multiply powers, you add the exponents. Now, if I threw out a question and you were just going to take a guess at it, any ideas what you think you would do if you divide powers? So say we're taking a to the fifth and dividing it by a squared. So in other words, when you multiply powers, you add the exponents. When you divide powers, what do you think you do? And if you answered you subtract the exponents, you're right. So in other words, a to the fifth divided by a squared, you subtract the exponents. And it's always the top one minus the bottom one. So it's got to be 5 minus 2, or in other words, that's a cubed. Now that should make pretty good sense, because think of a to the fifth as a times a 5 times, right? Over a squared would be a times a. So in other words, I can cancel out one pair of a's, another pair, and all I have left is 3 of them, and that's how you get your a cubed, and that's how you get the rule for dividing exponents. Now let's take a look at example 1. In example 1, they want us to simplify this. Well, what we're going to do is we're going to divide all the powers. So in other words, I'm going to put circles around the x's. So I have x to the negative 6 over x to the negative 6. I have a y to the fourth divided by y to the fifth. And then I have a z to the fifth divided by z squared. And what we're going to do is we're just going to divide each of those powers. So I'm going to have so many x's, so many y's, and so many z's. So first, let's take a look at the x's. So now to divide x to the negative 6 over x to the negative 6, remember, you subtract the exponents. So what I'm going to do is I'm going to take a negative 6 right here minus the bottom, a negative 6. So I'm going to take the top minus the bottom. To divide powers, you subtract the exponents. So that's a negative 6 plus 6, so that's x to the 0. Now let's do the y's. Take the top, which is 4, minus 5. What's 4 minus 5? A negative 1. And now let's do the z's. Take 5 minus 2, which is 3. Now I can simplify this up, because I know that x to the 0 is just 1 times y to the negative 1 times the z cubed, right? Or in other words, just y to the negative 1 z cubed. And that's my final answer. Now, suppose they wanted you to write your final answer with all positive exponents. Well, drop the y to the negative 1 down, which means the z cubed stays in the top, and the y to the negative 1, if you drop it down, it becomes y to the positive 1, or just y. So this answer right here and this answer right here are the same answer. It just depends how they want you to write the final answer. Now, I have example 1 rewritten. Now, I want to show you another way that you can always do these. Now, remember, we've said that if when you take an exponent, say I have x to the 6, what happens if we drop it down? So in other words, what happens if we drop that x to the negative 6 down? Well, it becomes x to the negative 6. So if we drop that x to the 6 down, it becomes x to the negative 6. Or say I have 1 over x to the negative 2. What happens if I move it up? Well, it becomes x squared. So it becomes the opposite, right, when you move it up or down. So that's another way that you could actually take this first example and simplify it. So really, we could use the multiplication rule when I do this. So I'm going to do that. So I'm going to take everything in the bottom and move it up. So my x to the negative 6 becomes x to the 6 my y to the 5th becomes y to the negative 5, and my z squared becomes z to the negative 2. And now I no longer have those in the bottom. So now, let's multiply our powers, because I have x to the 6 times x to the negative 6. Let's see, 6 plus a negative 6 is x to the 0. Multiply my y's. What's y to the 4th times y to the negative 5? Add the exponents. That's y to the negative 1. And finally, let's do our z's. What's negative 2 plus 5, or 5 plus a negative 2? And you can see that I'm getting the same answer, because x to the 0 is simply 1. Or in other words, what I have is y to the negative 1 z cubed. And that's exactly what I had in the other example. So really, you could do it both ways. All right, let's do one more example. And I'm going to use the quotient rule. So I'm going to divide the powers. So I'm going to divide my m's by subtracting the exponents. I'm going to divide my p's by subtracting the exponents, the z's, and finally the d's. Remember, up here, that's d to the 1st. So I'm going to have so many m's, so many p's, so many z's, and so many d's. Now let's do the m's. What's 4 minus a negative 2? That's 4 plus 2. That's m to the 6. Let's do the p's. What's 3 minus 4? Again, it's always got to be the top exponent minus the bottom. And that's a negative 1. How about the z's? What's 10 minus a negative 6? Well, let's see. Minus minus means plus, so that's 10 plus 6. That's z to the 16th. And let's do the d's. 1 minus a negative 2, which means 1 plus 2. That's d cubed. So this is one way I could write my answer. Now remember, if they want all positive exponents, I would drop the p to the negative 1 down, and it would become m to the 6, z to the 16th, d cubed, over p to the positive 1, or just p. So we've talked about how you divide powers, or in other words, the quotient rule for exponents.